Okay, so today we will just we will just solve question relevant to the standard deviation from the concept which we discussed in the last class. Okay, so now solve this question and try to do this quickly. So what is the answer?
X comma B.
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 The question is set A has elements 1, 2, 3, 4, and 5. Has standard deviation of X. What will be standard deviation for set B and set C? Okay. At first, we have set having elements 1, 2, 3, 4, and 5. And standard deviation for this is X. And we discussed two properties yesterday that if we add or subtract same element, same number from each of the element of the set, there is no effect on standard deviation. And if we see the B, its element are 11, 12, 13, 14, and 15. We can also write this as 1 plus 10, 2 plus 10, 3 plus 10, 4 plus 10, and 5 plus 10. Will this make any difference? No. So these are odd elements 1, 2, 3, 4, and 5, and you're adding 5 in all of these. Their old standard deviation is X, so the new standard deviation also remain X, right? We already discussed this thing in the last class. And if you see the set C is in the set B, we have 11, 12, 13, 14, and 15 having standard deviation of X. Now you are multiplying each of the element with 3. 3 into 11 is 33, 36, 39, 42, and 45, right? And we discussed this thing as well in the last class that when we multiply same number in each of the element, the standard deviation is just multiplied or scaled by that number. Old standard deviation is X. New standard deviation will be what is the multiple number multiplied 3 into old standard deviation, which is 3x. So standard deviation for B is X and for C is 3x. All right. Shall I move forward?
Yes.
Okay. Yeah, just solve this question and try to do quickly. Yes, the answer is C. I told you one thing in the last class that if you have a data set having any standard deviation and you are asked that you want to decrease or minimize the standard deviation by adding one more element, that is only possible when you are just adding element that is exactly equal to the average of that element or less than or a bit closer to the average. The rationale behind this concept is that what is actually standard deviation? Standard deviation is actually in the upper side, we have sum of deviation, scared sum of deviation, right? And now if you're adding one element equal to the standard deviation, equal to the average, that will become 0. But in denominator, there increase of 1. For example, they are at first 1,000 numbers, and now you're adding 2 more. This will become 1,002. But in the numerator, the value remains same. So in short, the standard deviation will decrease. So that's why if you want to minimize the standard deviation or decrease the standard deviation, just substitute the value that is exactly equal to the mean. In this question, we have a certain list of 1,000 test scores having average of 20, okay, and standard deviation of X. So average is 50 and standard deviation is X, where X is positive, okay. Which of the following two scores when added to the list must result in list of 1002 tests, okay, with standard deviation less than X? That is only possible when you are substituting both of the values equal to the average, right? And if you add any other element, any other number other than these, there will be increase in standard deviation because there will be some value added, and that's why the standard deviation will not decrease. Try this question. First of all, tell me one thing. Consider the first one. Okay, there is one thing which okay, first see the A. We have A is equal to 10, 20, 30, 40, and 50. What is B? B is minus 20, minus 10, 0. That is minus 20, minus 10, 0, 10, and 20. Can we write this as 10 minus 30, 20 minus 30, 30 minus 30, 40 minus 30, and 50 minus 30, right? This means this and this one are having same standard deviation. Agree on this point? Because you just subtracted same value from all of the elements. Now if you see the C, that is 0, 10, 20, 30, and 40. Okay, so now this is, you can also write this as 10 minus 10, 20 minus 10, 30 minus 10, 40 minus 10, and 50 minus 10, right? So from till now, we are pretty sure that A, B, C are having same standard deviation. Even agree on this point? This point? If yes, then I will proceed further.
Yes.
Now the next thing is, what is the mean of first set, arithmetic mean of first set? That is 30. What is arithmetic mean of the second set? That is 0. And for the third set, that is 20. Now I told you one thing, that if you add any value that is at a greater distance from the mean, the standard deviation will be greater. And if you add 60 in this, and 60 is how much above 30? Plus 30. How much above B? Plus 60. And how much above C? Plus 40, right? Now you can see that this much increase in deviation by adding 60. So if you add 60, the standard deviation will be, B will be increased by the greatest amount. Afterward, if you add in data set C, that will be increased less than B, and this will be increased less than A. So whenever you see just such questions, I just take the sign from first. This is C, which is greater than C, B, which is greater than C, which is greater than A. Got the point? How the standard deviation of B is greatest, how afterwards C, and how then A.
You told us that when we add the same value, the standard deviation remains the same.
Yes.
So I thought this means like adding each number by 60.
No, not 8 to each set. Adding 60 in added to each set, not each element of each set. Added 60 when 60 is added to each set. There is never mentioned that 60 is added to each element of each set. To every element of each set. Got the point?
Yeah, I mean.
If the standard deviation of A, B, C aren't equal initially, then how would we calculate the standard
Then we
deviation
can't do.
after added 60? Then we can't do.
Then we can't, because we don't know the, remember, you won't be asked an exam to find the standard deviation directly. Just like this set A, you need to check the formula and find the standard deviation. If you ask to compare the standard deviation, that is different scenario. But in this scenario, how can you compare if the original standard deviation is not same? The other way is you need to check, first of all, find the standard deviation of each value, but that will never be asked in exam. In this scenario, all of these are initially having same standard deviation. So you just need to see that if you add 60 in these, what is the greatest change? Which of the following has the greatest change in standard deviation? And in this scenario, just see the mean and see which of the following values greater distance from mean. The greater the distance from the mean, the greater will be the standard deviation. Got the point?
Okay.
And what about minus sign, minus 20, minus 10? They will remain the same.
Minus 20, minus 10. Both of these are same. Because for becoming B, we are just subtracting minus 30 from each of the element of A. 10 minus 30 minus 20, 20 minus 30 minus 10, 30 minus 30, 0. Got the point? You are just subtracting same value from each of the element. That's why the standard deviation is same. And likewise for C, you are subtracting 10 from each element. That's why standard deviation from A, B, and C, initially standard deviation of A is equal to B is equal to C. But after adding 60, there will be a change which you need to figure out in this question. Okay.
In last class, you told something about range and standard deviation. Can you repeat it?
Range
again?
was different thing. I told you that if you're having comparing, that is for the comparison part, not for finding the exact standard deviation. If I told you quantity A, this is quantity B, and ask you standard deviation of set, for example, 1, 2, and 4, and standard deviation of set 2, 4, and 9, you can clearly see that the range of this question is 3, and the range of this question is 7. So that's why this is a greater, having a greater standard deviation. So you are having a smaller values and same number of elements, then you can use the range concept. Otherwise, you can't use that.
Okay.
Yeah, this question will just figure out all of your doubts. First question is saying which of the following distribution of number has the greatest standard deviation. First of all, try to see for these three having same number of elements. One is -3, 1, 2. One is 3, 5, and 7. And one is 0, 2, and 4. I told you one thing, that if you are having data set with same number of elements, just see the range. The range of this is 5, the range of this is 4, and the range of this is 4, right? Straightforward. This data set A is greater than C and D and E. So you can right now you can ignore C and E. Now see the B and D. B is -2, -1, 1 and 2, and D is -1, 2, 3, and 4. Okay, now see the range. The range of this is 4, and the range of this is 5. So this is also ignored. Now we are left with A and D. Now let's see how can we compare A and D. A is -3, 1, and 2. D is, this is A, and D is -1, 2, 3, and 4. How can we compare these now?
From the mean.
Directly by formula also.
Yes. There again,
can compute.
Whenever you will see such question, there is always a pattern. If you take -3, 1, 2, and this is -1, 2, 3, and 4. So what is the mean in first question? The first mean is 0. And here mean is how much? Mean is 2. Now see the deviations. -3 is how much below 0? -3. This is +1 above, and this is +2 above. And if you see this one, 1 is 3 times below the mean, 2 is 0 below, 3 is 1 above, and 4 is 2 above. Now if you see the both of these part, aren't the upper portion of standard deviation formula will be same in both of these? Because deviations in both of these are exactly same. And if any son say about the 0, that is 0, that doesn't matter. This is -3, -3, +2, +2, 1, and 1. If you use the formula, the upper portion will be same for both of these, but the difference will lie in the denominator, because here n is equal to 3 and here n is equal to 4. So same value divided by 3, this is same value divided by 4. That's why this quantity A is greater than quantity B. Got the point? Got the point or not?
Yes, got the point.
So in such questions, remember, you will not be directly asked to find the standard deviation of such values. They will always ask you some logical ways for the question. They will never directly ask, just like I have seen some prep guides say this, ask you to find the standard deviation of the numbers of the values. You will never be directly asked, or you could be asked to compare. So in such scenario, if they're having the same number of elements, use the range. And if you are about to compare the two different data set having different number of elements, then try to see the deviations. More or less, this concept will be used. But still, if this it is not, you can go for the formula, but till now I haven't seen any question that directly use this formula, that in which you need to use the whole of the formula to find the value of the standard deviation, right? But if still anyone want to use, he or she can use. Okay. And this is highly tested. This way of testing question for standard deviation is pretty much common. And try to think of this. I told you earlier that in such question, there's always a pattern. That always something you need to figure out. If you see in all A, B, C, and D, first 4 elements are same, isn't it? For time being, don't consider 6, 7, 4, and 10. For time being, not consider this. If you see the first 4 elements, 3, 6, 9, and 12, what is the mean of this? The mean of this is, because these are in arithmetic progression, so just because the number of elements are even, just see the average of middle 2, that is 7.5. Now just see all of these elements, greater the distance from the mean, greater the standard deviation, the same concept which we discussed earlier. So for first, there is a deviation of -1.5. In the second one, there is a deviation of -0.5. In the third one, there is a deviation of how much? -3.5. And in the last one, this is 2.5, right? Now you can quickly figure out. First, tell me one thing. If I write deviation -1.05 or +1.05, will that make any difference?
No, because you square anyway.
Yeah,
Because we're gonna square it.
exactly. Because we are taking the squares of all of the values and summing those. And that's why doesn't matter whether I take deviation in positive or in negative. So that's why you can, the greatest is of C, after that D, after that A, and then B. So this is B, A, D, C. I wrote in inverse, this is B, A, D, C in ascending order. This is in descending order. Got the point? Shall I move forward now?
Yes.
A, B, C. Okay. This is the same thing. Just leave this. I will ask this question at end. This is a very good question. Leave this question for now. Okay, just tell me what is the answer to this question. Just by saying, you don't need to solve this. The variance of set with values 3, 3, 3, 6 times 3, and variance of set with values 4 times 5. What is the answer?
C.
D. C.
C. First of all, what is the variance? Can anyone tell me the variance of this question?
Square of standard deviation.
Just tell me the exact value. What is the value?
0, 0, 0.
0, because all of the values are they are single values, so that all of these are equal to the mean, and deviation from all of the value from mean is 0. That's why there is no standard deviation. Standard deviation is 0 in both of the case. And if standard deviation is 0, variance will also be 0. Okay, what is the answer to this question? Anyone? Don't start solving. First think what is happening in the question. And just add
0.
one more thing. None or 1, all of these. All 1, 2, and 3. Now tell what is the answer.
Five. All of this.
What is the answer?
This.
All of the above.
All of the above. Okay, so one vote for all of the above. Any other? Number 1 only. Okay.
Standard deviation cannot be negative, yeah?
Yes. I'm just amazed how anyone is saying minus 1.5
Oh, 1 and 2,
minus
1
10.
and 2. Yeah.
The answer to this question is none. The thing is, first of all, standard deviation can never be negative. Next thing is you have minus 7, minus 5, minus 3, some negative integer, 0, 1, 3, k, and 7. How you could have a negative 0 standard deviation? 0 standard deviation mean all of the elements are equal to the mean. But in this scenario, there must be some standard deviation greater than 0, which means that you don't need to find. But we need to know that standard deviation is not 0 in this scenario. And standard deviation can never be negative. Remember, consider this as a distance, so that you can remember this can never be negative. Okay. The answer to this question is none. Yeah, try this. This is another way of testing. We already discussed this, but just to give an idea, try this. What is the answer?
2 and 3.
2 and 3.
Yeah.
Okay, let's see. Your data set having values A, B, and C. Straightforward, this is not possible because you're not subtracting same element from same number from each of the element. At first you are subtracting 2, then you are subtracting 4, right? So A is not possible. Let's see the B. Yes, because you're subtracting same number from each of the element. Now see the third one. We have A, B, and C. First of all, if we subtract C, this will become A minus C, B minus C, and 0. Now, if you add A, this will become 2A minus C, this will become A plus B minus C, and this will become A. Isn't this the same as the third one? That's why the standard deviation of this will also be same. Because I am subtracting same number from each of the element and adding same number in each of the element. That's why there is no effect on the standard deviation. The person is saying that in an MBA entrance exam, scores are calculated by adjusting a student score using the formula. Okay, we are provided with this formula, where X is the original score of student and Y is the adjusted score. Okay. If the standard deviation of original score for X is 450, then what will be the standard deviation of the adjusted score? This is the exactly same concept which we discussed earlier, that adding or subtracting and multiplying and dividing. We have formula Y is equal to 3 by 2 into X plus 55. And this is the old score, this is adjusted score. And okay, so whatever the new scores are, that will be found, that we can found using this formula. We know the standard deviation of old one, which is 450. All of the standard deviation of original scores of all of the student took is 450. Now, what will be the standard deviation of adjusted score? See, this is multiplying and this is adding. We are adding 55, but we are multiplying 1.5 or 3 over 2 with X. So there is only change in standard deviation when we are multiplying, but when we add, there is no effect on the standard deviation. So the standard deviation of the adjusted score will be only 3 by 2 into X, which is 3 by 2 into 450, and which is exactly, someone said 675. Just remember, when you're asked in this form, and this is another pretty much common, and in this, I'm already provided you with the equation, but in such question, you need to first form the equation and then find the standard deviation. Just remember one thing, that standard deviation will only change when you are multiplying or dividing, but when you're adding or subtracting, there is no change in the standard deviation, right? So in this scenario, standard deviation for all of the standard deviation for X is 450. 450 into 3 by 2 is at least 675. And this 55 has no role in finding the new standard deviation. Everyone got the point? Okay.
Yes.
Now let's move to the a bit tricky part. Leave this. This is easy. Try this at your own. In this, you need to use a formula. You already know that you need to find the value of X, and you will get two values of X. One is positive and one is negative. But the question already says that X is positive, so you will take that value. Try to solve this up later. Okay, let's move further. Try this question. First of all, not this question. Yeah, try this question. We are given that we have set S and set T that satisfy the condition that all elements in set S are in set T. Okay. First condition is all the number of element in set S are in set T. For example, for time being, just consider any value and the number of element S or in T. Okay. The next thing is the average is equal, right? There is one more condition: set T contain one element which is not in set S. So it contains one more element. So how can you think of this question? Anyone? How someone come up with D and other one come up with A?
I came up with D, but now I think it's A, since we are going to divide it and
So I
individually.
think,
Denominator.
I think the last number that
30
you're adding in
divided
T
by
must be
5.
the average number.
Exactly. That's the concept yesterday. For example, you have 1 S is 1, 2, 3, 4, and 5. And T is also 1, 2, 3, 4, and 5. For time being, number elements are equal. Now you have one more. The question is T contain one which is not in S, but their average is same. Now if you see the average is same 3, the average is same 3. But if you find the standard deviation, the upper portion will be same, the sum of square deviations will be same, but the only difference will be in the denominator, right? This is same and this is same. Total number of elements in first is 5, in second is 6. That's why quantity A is greater. The only takeaway is if you are adding one more element and having a same average, that's mean you are adding exactly equal to the average. Getting the point?
But this example is not exactly mimicking the question, right? Because you have added 3 in T, but 3 is also in S. You should consider some other example, right?
Just give me some example.
Yeah.
Just give me some example. For example, if you say that T contain,
Yeah.
okay, you are giving that, for example, I will say 2, 4, 6, and 8, right? So this will be 2, 4, 6, and 8, and one element 5.
Yeah. Now it's
This is same.
exactly.
I was just giving the idea of the concept, that's why. Got the point? Okay. First of all, try this, then we'll move to this question. Try this question. We have just 2 more questions for now. Just try this question. This concept came repeatedly in the hard section of the exam. Same concept, which I tried to explain in the last class, but the class seemed to be a bit sleepy. What can I say in that time? So that's why no one considered up till that time. But now try to solve this question. You can also think of this a bit logically. You can also prove this using the formula. First, try to do this using formula. I don't want to go into the explanation part because that will take too much time. But the idea is, if you're having 2 sets, for example, A and B, and this is number of element, this is mean, and this is variance. For example, we considered a case in which the number of element in B is twice the number of element in A. If this is n, for example, this is 2n, and mean is same, I call as m, and variance is different, was different. For example, 26 and 59. And I asked that if I make a third data set, which is the combined form of A and B, to having total elements 3n, mean First of all, what is the mean of that data set? I'm just combining the data set A and B. And if both are having a same mean, the combined data set would also have a same mean. And I asked that what is the variance of this data set? So I show you from the formula that how we do that. That final result was that will be just the weighted average of the two variances. Just consider this as we do in the weighted average. We know the two averages, we know the number of elements, just we find the overall average. Likewise, just consider these two averages and these two a number. Just find the combined average, that will be the variance of this set, which is the combination of set A and set B. You want me to go to the explanation, or you can see yourself from the recording of the class? Because if I go to that part, that will take time. But you got how we can find the variance of the data set, which is a combination of two data sets having different variances and same mean. The condition is the mean must be same, otherwise we can't do that way. So that will be just the weighted average of 26 and 59 having number of elements n and 2n. So in that case, that was n into 26 plus 2n into 59 divided by 3n. You get, I don't remember, 48 or whatever the value is. Okay, so in this question, we have two data sets. One is S and one is T. Okay. The standard deviation of both are different, but the number of values and mean is equal. Okay, so just consider this. First is S and T. This is number of element. This is mean. And for time being, consider the variance. Then from variance, we will go to the standard deviation part. Number of element is same, for example, N. And the mean is also equal, for example, M. And the variance is different. Let's call this X, let's call this Y. And if we combine this to Z, so total number of element will be 2n, mean will be M, and we need to find first this thing. So that will be just the weighted average of this. So the standard deviation, first see the variance of our all set. That will be just the weighted average n into X plus n into Y divided by 2n, that is X plus Y divided by 2. This is the variance of the data set Z. So what will be the standard deviation? That will just the square root of this value, X plus Y divided by 2, right? If this is the variance, what is standard deviation? That is just the square root of variance. We know the variance, the standard deviation will be just square root of X plus Y over 2. So this is X plus Y over 2. The sum of standard deviation of A and B. If the variance of data set S is X, so what is the standard deviation? That will be under root X, and this will be under root Y. Now we come up with this value. Quantity A is X plus Y divided by 2, and quantity B is under root X plus under root Y. So how can we proceed further? If we have this quantity comparison question, having this values under root of X plus Y over 2 and under root X plus under root Y, how can we solve this?
By mirroring method.
Yeah. By mirroring, how can we solve this? Quickly. Just take the square on both sides. This will be X plus Y by 2. This is, we just open the formula X plus A plus B whole square. That will be X plus Y plus 2 into X into Y. And just multiply 2 on both sides. This will be X plus Y. This will be 2X plus 2Y plus 4 into under root XY. And just subtract X and Y on both sides. This will be 0. This will be X plus Y plus 4 into under root XY. Now can value of X and Y be 0? I'm asking in this scenario, can the value of x and y be 0?
No.
Yes, exactly. That's why quantity B will be greater. I need to explain that method. You are confused in which part of that method? How I consider the weighted average?
No, I get the weighted average part, but just explain it again if you can, like from the start. I don't know about the others, but I'm like a bit confused.
Yes.
Okay.
Uh, okay. First of all, let me explain that how that is equal to the weighted average. So let's consider two sets, A and B, and this is number of elements. This is mean, arithmetic mean, and this is variance. And we consider a case that in which number of element in B is twice the number of element in A. So I consider this as n, and this is 2n. And mean is equal, which is m, and variance is 26 and 59. So I ask that if I consider a third data set, which is a combination of data set A and B, so total number of elements are n plus 2n, which is 3n.
Aren't number of elements equal?
I'm just first of all giving you the idea how that is equal to the weighted average.
Okay.
So another thing is, if both of the sets are having a same mean, by combining both, the overall mean will be remain same. They ask what is this value, and let's see both of the scenarios. If we have A having n elements, and I consider that, for example, if that is x1, x2, x3, x4 up to xn, right? And mean is m. So what is the variance? Actually, variance is equal to sum of square deviations from mean divided by total number. And we know the variance for first data set, that is 26. 26 is equal to, now what is the mean? Mean is m first value division m1 whole square plus mean minus x2 whole square plus up to mean minus x and last value whole square divided by n, right? So this thing, mean minus x1 whole square plus mean minus x2 whole square plus this value up to mean minus xn whole square will be equal to 26n, right? Till now, is there any confusion?
No.
This was the first data set. Now let's see the second data set, which is B. Total number of elements are 2n. Variance was 59. And okay, and I consider elements are y1, y2 up to y2n. Y2n first up to son. Okay. Now see the variance. Variance 59 is equal to sum of the deviation from mean. That is, I consider mean as m. That is m minus y1 square plus m minus y2 square plus up to m minus y2n square divided by 2n. That's why the sum y minus y1 square plus y minus y2 square up to m minus y2n square is equal to 118n. Is this 11859 into 2? 18, yeah, 118. Now we know this thing, and we know this thing. Now, if I consider the data set C, in data set C, elements are 3n, that is x1, x2 up to xn, y1, y2 up to y2n. And there is one important thing, that mean is same, which is m, and we need to find the variance. So what is the variance? Variance is equal to mean minus x1 square plus mean minus x2 square up to mean minus xn square plus mean minus y1 square up to mean minus y2n square divided by n plus 2n. And if you see closely, we already know these values. This value is equal to 26n, and this value is equal to 118n. So this will be 26n plus 118n divided by 3n, which is whatever the value is. This is exactly the weighted average thing. If you consider this as average, these are the number of elements. So this is exactly the formula for the weighted average. So that's how you get the formula, that how you can find the combined variance for the data set, which is a combination of two data set. But only term and condition is the mean must be same, because you're having a same mean and you're to get 26, and this mean must be equal to m. But if it's not equal to m, then you cannot solve this way. So that's one exam you will get if this type of scenario. In that scenario, mean must be equal to the other two data sets. Now, got the point?
Yes.
Now, what was in the question? In the question, we have one is S, one is T, and number of elements are equal, NN. Mean is also equal, which is MM. And let's suppose the variance is X and Y, and U combine form Z. Number of elements is 2n. Mean is also M. You need to find this thing. It is straightforward. The weighted average will be used. Variance into number of element plus variance into number of element divided by total number of element, which is x plus y over 2. So if this is variance, what is standard deviation? That will be square root of this, which is x plus y over 2. Now just see two quantities. Quantity A is the standard deviation of the combined set, which is x plus y over 2. And quantity B is the standard the sum of the standard deviation of two sets. Standard deviation, the variance of first set is x and second is y. To find the standard deviation, just say the square root of this. So this will be x plus y. So just now use the mirroring technique and just proceed further. You will get to know that quantity B is greater. So everything is understood now.
Yes.